Hello everyone, welcome to IIT's GATE classes. Today I'll be discussing the aptitude solutions from GATE Aerospace paper 2021. So let's begin. Here's the first question. Two identical cube-shaped dice, each with faces numbered 1 to 6, are rolled simultaneously. The probability that an even number is rolled out on each dice is. So let's start by first calculating the total number of cases. So that comes to 6 into 6, which is 36. Since there are two dice and 6 numbers on each, it comes to 6 into 6. Now, for even numbers, the choices that we have are 2, 4, and 6, which are 3 choices. So, and since there are two dice, we have 3 into 3, which is 9 choices in total. So the final answer, the probability, let's say P, it comes to 9 divided by the total, which is 36, which is 1 by 4. So the correct answer is D, 1 by 4. Let's move on to the next question. Rounded plus and rounded dot are two operators on numbers P and Q such that P rounded dot Q is P minus Q and P rounded plus Q is P into Q. Then we need to evaluate this expression. It's a straightforward question, so let's directly evaluate it. We have 9, rounded dot means minus, put the brackets properly, so 6 into 7, rounded dot means minus, 7 into 6 minus 5. This comes to 9 minus 6 sevens are 42, minus of 7 into 1, which is 7. This comes to 9 minus 42 minus 7. The final answer is minus 40. So D. D is the correct option. Next question. 4 persons P, Q, R and S are to be seated in a row. R should not be seated at the second position from the left end of the row. The number of distinct seating arrangements possible is. So let's mark the seating arrangements. There are 4 positions, 1, 2, 3, 4. The total number of ways that 4 persons can sit is 4 into 3 into 2 into 1. This is 24. From this, I'll subtract all the arrangements where R is seated in the second position. The final answer will be the required answer then. So let's take the 4 positions again, and in the second position I'm going to put R. So this can be filled in 3 ways with the P, Q and S. This can be filled in 2, this can be filled in 1. So 3 into 2 into 1, it gives us 6. We need the arrangements where R is not seated at second position. So the final answer is 24 minus 6, which is 18. So C is the right option. Moving on to the next question. On a planar field, you traveled 3 units east from a point O. Next, you traveled 4 units south to arrive at point P. Then you traveled from P in the northeast direction such that you arrive at a point that is 6 units east of point O. Next, you traveled in the northwest direction so that you arrive at point Q, that is 8 units north of point P. The distance of point Q to point O in the same units should be. Since we are in a planar field, it makes sense to use a coordinate system. So let's start by marking the point O. O will be over here. I'm starting from O and moving 3 units to the east. Let me mark that also for reference, the directions. North, south, this is east, and this is west. Also, I'll be using the coordinate system, so X and Y. So after traveling 3 units east, then I travel 4 units south to reach point P. So this is 3 units and this is 4 units. Then from point P, I travel in the northeast direction to reach a point which is 6 units away from point O. So this is 6. Then I travel in the northwest direction. Northeast was over here. Northwest is over here. So travel this way and I reach a point which is 8 units away from point P. Let me start with point O as the origin, 0, 0. I travel 3 units east to reach 3, 0. The x coordinate only has changed, the y coordinate is the same. Then when I travel south, I reach 3, minus 4. And finally, when I reach this point Q, I'll have reached 3, 4. So the distance OQ, that is given by the distance between between the origin 0, 0 and the point 3, 4. So applying distance formula, we are going to get that as 3 square plus 4 square, the square root of this. That comes to 5. So option C is the correct option. Moving on to the next question. Some football players play cricket. That's the first statement. The second statement is all cricket players play hockey. Among the options given below, the statement that logically follows from the two statements 1 and 2 above is. For this question, we need to draw Venn diagrams according to the statements. According to the first statement, the Venn diagram will be some football players play cricket. So, taking that as football and this as cricket, this will be the corresponding Venn diagram. Some of the football players, they play cricket, which is given by the intersection. Now, according to the second one, all cricket players play hockey. So, if I take this as a set of players who play cricket, since all of them play hockey, they are covered by this. Covered by the circle which represents hockey players. So combining these two, I'm going to get the hockey players, the cricket players, and the football players. Cricket and hockey. This is the given information. Now we just need to verify the options. No football player plays hockey. That's not true. Some football players they will be playing hockey. So this is not true. Some football players play hockey. This is true. All football players play hockey. That is not necessarily true. And all hockey players play football. This is also not necessarily true. So only option B is true, and that's the correct option. Moving on to the next question. In the figure shown above, PQRS is a square The shaded portion is formed by the intersection of sectors of circles with radius equal to the side of the square and centers at S and Q. The probability that any point picked randomly within the square falls in the shaded area is. We have the probability P given by shaded area by total area. First, we have to recognize this. We pick any point randomly within the square. Uh, the probability of finding that point lies in the shaded area is given by the respective areas itself. So the total area, let's calculate that first. The total area is the area of the square, and that comes to r into r, which is r square. Now for the shaded area, we'll have to do some calculations. The shaded area, it's shaped like this. There is one sector over here and another one over here. Now I can mark this as 2 times. I'll mark the diagonal first, then I'll take the curved surface only on one side. Since I'm multiplying by 2, it will come, the bottom part will be also accounted for. I'll simplify this a little further. So first I'll get the entire sector, this, minus this triangle. Okay. When I subtract these two areas, this sector and this triangle, I'm going to get this shaded area. So now we apply some formula over here, which is 2 times area of sector is half r square theta. Theta is 90 degrees over here, so pi by 2 minus the area of this triangle. This is a right angle triangle again, so half base into height. Base is also r, height is also r. Cancel out the 2's, and the final answer for the shaded area, for the value of the shaded area, we get it as taking r square also common, pi by 2 minus 1. Substitute in the probability equation, we get p is equal to r square by pi by 2 minus 1 divided by r square. The final answer is pi by 2 minus 1, which is option C. Moving on to the next question. In an equilateral triangle PQR, side PQ is divided into 4 parts, side QR is divided into 6 equal parts, and side PR is divided into 8 equal parts. The length of each subdivided part in centimeter is an integer. The minimum area of the triangle PQR possible in square centimeter is. Since it's an equilateral triangle, we have PQ is equal to QR is equal to PR. Other than this, we have PQ by 4, QR by 6, and PR by 8. That is, they are divided into some parts. PR is divided into 4 parts, QR into 6, and PR into 8. And each of these is an integer. So these are integers. So to find the minimum area, we need to find the smallest side length also. To do that, we take LCM of 4, 6, and 8. That comes to 4, 6, 8. See, 2 2s are, 2 3s are, 2 4s are, then 3 1s are, 2 1s are, and 2s are. So it comes to 2 into 3 into 2 into 2. This comes to 6 2s are 12 2s are, 24. This is the smallest side length possible for this triangle PQR. To find area of triangle PQR, we go for half. Let's say the side lengths are AB, the PQ is A and QR is B, and C is the angle between sides PQ and QR. So applying half AB sine C, we get the final answer as half into 24 into 24 into sine of 60 degrees. 60 degrees because it's an equilateral triangle. So all angles inside are 60 degrees. Simplifying this, we are going to get half into 24 into 24 into root 3 by 2. 12s are 12s are 12 into 12 is 144 root 3. So the option is D. The correct option is D. So that was all. Thank you.